Good morning.
Good morning.
Sorry, we're running behind. Good morning.
Okay, I think we have a quorum. And I'm enabling screen sharing. So we have two items, main items on the agenda today. One, I guess, a presentation from Joe and Peter on reproducibility, and one from Sue on geospatial visual analytics and visualization. So before we get started, any announcements? Anything you want to get off your minds? Okay, if not, so everyone's happy in their own location. So, okay, so we'll get started. So first, I guess Peter and Joe, they'll be talking to us about reproducibility, and that is one of the key angles of this fellowship. And so that project essentially is cross-cutting, as Chauvin introduced in the very first series, first talk in this series, that like I guess we are looking for things which can be reproducible in some ways, like the Jupyter notebooks that can be shared with others. So Joe and Peter have a lot of experience in this kind of an area, and they will help guide us. How do we make our research products generated through this fellowship shareable? And I guess in more general sense, how would we make our research in general more reproducible and replicable? So Joe and Peter, take it away.
Well, can everyone see the slideshow?
Yes,
Yeah.
I can.
Thumbs up. Cool.
Okay, great. And can everybody hear me, I guess, is the other thing.
Yes, I can. Yep.
Perfect. Okay, great. So thanks for the time, Anand and Chauvin and everyone else. Yeah, Joe and I sort of have this cross-cutting project that is maybe a little bit different than some of the other projects, but we wanted to do a quick sort of like, never sufficient, but a good start kind of landing pad for the idea of reproducibility and replicability as it applies to what we're thinking about and as we can fit it into this larger project. So again, our particular project in this larger fellowship is to really help all of you guys or work with you guys to improve the reproducibility, replicability of your own projects and potentially explore some of the ways in which we can standardize those things within the field and sort of as it relates to software and computational reproducibility in particular. So just really quickly, Joe, next slide, please. Our project sort of has three main objectives. One is really to facilitate the adoption of reproducible research practices among the fellows and among the discipline more widely. A second one is really to try to conduct reproductions and potentially replications of your guys' projects. And we'll return to why this is important a little bit later on, but that's one of the main things we want to do is really try to establish credibility and reliability of your work by directly reproducing and trying to replicate your work. So we want to connect and work with you guys to do that. And we'll talk about some of the ways we see potentially starting that up towards the end of the presentation. And then finally, working in parallel with that, or with that objective, is to really create educational materials that accelerate our first objective, getting this adoption more broadly, and then also accelerate sort of the establishment of your work and the work of this program in the field, and then more widely amongst policymakers and things like this by doing reproductions to show that this work is sort of credible and very reliable. So those are our three main objectives. And just so we're kind of on the same page, we'll throw out a couple of definitions to you guys, which we can quibble and fight about if we want. But when we're talking about reproducibility, Joe and I are generally adopting the definition that's been used by the National Academy of Science, Engineering, and Medicine in their report from about a year ago. And that's basically when we say whether research is reproducible, we're looking to obtain consistent results or the same results using the same data, the same computational steps, methods of analysis. So basically you can think of it as same data, same code, same results is the simple way to think about it. And if we talk about replicability, Joe, the next slide, what we're thinking about there is basically we're looking at obtaining consistent results again across studies aimed at answering roughly the same question, but this time we've got different data or slightly tweaks to the method. So same question, different data usually, generally similar methods. So that's what we're talking about when we say replicability. And now Joe and I recognize that these are maybe not necessarily always the definitions. And there's a really good paper a couple of years ago put out by Barba that basically shows that these definitions can be varied in different disciplines. And I only bring up this little table from her paper because, you know, a lot of the people in this group probably have a background in the computer sciences. And unfortunately, for us at least, in the computer sciences, they directly invert these two terms. So just kind of for the record, so everyone's on the same page, you know, we're talking in the opposite way of computer science. So hopefully that won't be too much of an issue as we go forward in these things. But, you know, Joe and I are veering towards the definitions that we provided because those, as you can see here, this B1 terminology is the terminology that we put forward. And it's used across many different fields and is sort of kind of more widely adopted. And that's kind of why we went in that direction. And so the next slide really here is about why is this important, right? Why do we want to press forward with this in general? And really it's because reproducibility and replicability, particularly replications, are really important self-correcting mechanisms in the scientific method, right? And if we think about this, what we're really talking about reproducibility and replicability being are means to an end, right? So Joe, the next slide. The end being, you know, when we think about science, science is really trying to build these explanatory structures that tell us about what's going on in the world and then scrupulously testing those structures, right, by repeating those studies so that we can then know that what we believe is true is actually true, right, or within some bound of certainty. And, you know, we don't judge our scientific discoveries necessarily by the fact that we can reproduce them over and over again, although that's part of it. We judge them by how well they explain the world, whether they're offering some kind of clarity to a previously unanswered question and things like this. But important steps on way to establishing those understandings is reproducing, replicating this prior work. And ultimately, you know, when people talk about reproducibility, replicability, they often kind of substitute this idea of truth and falsehood. And science is really more about degrees of certainty, right? So we use reproducibility and replicability to make more certain our explanations. So we come up with sort of the best way of understanding the world at a given level of knowledge, right? So doing your studies again and again and trying to expand them with new data sets and things like this lets us kind of establish how much credibility, how much reliability we should give to our different explanations and studies. And then Joe, one more slide. And just like conceptually in geography, since we are kind of in this geospatial institute, a simple kind of conceptual example would be something like, well, if we do an original study looking for some effect or something, for instance, or establishing some relationship at one particular location, an interesting question in geography is then, well, can we replicate the same study with the same data at the same location? And then if we start to move locations, keep most of the things the same, but get new data from new places, the second law of geography says we'd expect heterogeneity, but if we start to see the same effect and the same relationship in multiple locations, we can start to create kind of spatial boundaries of belief where we think the relationship or effect holds, which allows us to potentially build theories about what's going on in these different locations and potentially move all the way towards covering laws. We may not be able to get all the way to sort of like physics laws, but we can potentially get to covering laws that explain what's going on in different parts of the world. And this is kind of that march towards explanation in just a very simple toy geographic example here. So it's adjusting belief as we go up and down as we get results from our studies by doing replications, by doing reproductions in different locations and things like this. And so we kind of readjust our I don't want to say faith, but our credibility in a specific effect or relationship through space and through time. And so I'll hand it to Joe to pick this up on the COVID theme in particular.
Well, thanks for that really clear introduction to our NAR issues, Peter. So when we think about why think about reproducibility and replicability, or R&R? I'll shorthand that for now on, so I don't trip over my own tongue. In COVID research, knowledge of COVID-19 is evolving rapidly. Just think about how science was struggling to figure out how this disease was transmitted, what its symptoms were, whether children were affected or could transmit it, et cetera, et cetera. Our knowledge has been changing almost by the day as the pandemic evolves. So knowledge is evolving rapidly. And in that rapid involvement of knowledge, our public health officials depend wholeheartedly on reliable COVID-19 research. And so any crisis of confidence or reliability in that research then creates a public health nightmare in terms of trying to create adequate and appropriate policies and get the public's trust to follow those policies, right? And so we've seen already evidence that open research, that is research that is fully replicable and reproducible, has been accelerating the pace of discovery in the context of COVID-19. Just yesterday, I was looking at the medRxiv and bioRxiv preprint servers, where researchers are publishing their work as it begins the peer review process with open data on those servers. And there are over 9,500 articles on COVID-19 already published. It's incredibly quick pace of publication and research. And some of the particular themes or contents of those papers and similar open data repositories on COVID-19 involve tracking cases and numbers of deaths by geographic area, tracking geographically explicit government interventions, and then also correlating those with databases on mobility and changes in mobility in terms of the public observing or failing to observe those government interventions. And so this has also been paralleled with an accelerated peer review process where many of the articles have been published with open access. And so unfortunately, this rapid pace of research has led to a couple of retractions and perils due to irreproducible data. And I'll just speak to two specific examples to COVID-19 in this case. So earlier this summer, there was a debate on whether hydroxychloroquine could be used as a treatment to cure or reduce the symptoms of COVID-19. And a couple of papers were published in prominent medical journals, The Lancet and New England Journal of Medicine being two of them, that were finding an increased chance of death with that treatment. Unfortunately, those studies were based on a proprietary closed database of patient records maintained by Cybergis. And independent researchers were not able to reproduce those results. And the authors of the papers were not transparent in providing data from the proprietary database in order for the results to be confirmed. And ultimately, the two papers had to be retracted. And of course, this was a highly political treatment. And so this kind of back and forth in science of publishing and then retracting really degrades public trust in the scientific process. And another example of a missed opportunity on genomic experiments or genome sequencing of the virus is that researchers published a paper in Nature, Schrimmel et al. In 2020, where they were finding that 68% of all of the studies, and there are over 12,000 of them, were missing key location metadata on those experiments, which of course take away our ability to do things like trace the diffusion, the spatial diffusion of the disease using genomic sequencing, because we don't know where the sequences are coming from. And so we need reproducibility and open science to establish the reliability of our research and to be able to check the reliability of the research. And this means being able to weigh alternative explanations for theorized mechanisms, and also the ability to aggregate numerous research studies as cases into meta-analyses to build on theory. And it's also super important to make and implement better policies. And so one of the biggest challenges with R&R is that there are many necessary conditions, but few sufficient conditions for achieving reproducibility. So many things are likely necessary for a piece of research to be reproducible. That means in other words, let's think of this in terms of the weakest link of a chain. There are many different elements that we need to have all tight and interconnected in order to call research reproducible or in order to successfully reproduce research. And if any of those links is broken, missing, or weak, it's going to be difficult to reproduce the entire thing, right? And so some of those individual links I'll start to speak to in the upcoming slides, but that includes having available data and code, a clear analytical framework, and proper and open reporting of the research process. And so the other side of this is that no link in that chain is sufficient in and of itself for research to be reproducible. You know, there was an open database of those genomic sequences, over 12,000 of them, but most of them were missing a key link, which is the location metadata. So although the data was open, it's not enough in and of itself. And so necessary and sufficient, the properties depend on the context of the research, both geographic, temporal, and also the computational environment. And that means that the particular requirements of data and materials kind of change by study in terms of different things might be more confounding than others, depending on the type of study and the context of that study. And then this is even more complicated for replication. So if we're just trying to computationally reproduce something, it might be enough to simply have all of the input data and the code in order to run the analyses and get the final output tables, statistics, or figures. But when it comes to replication, we also need to have a very tight connection between the data, methods, materials, and code, and the analytical framework. Because when we try to replicate, we're also trying to intentionally change one of the confounds or some of the context of that study in order to determine how reproducible that study is or how generalizable that study is. And so it's been very exciting to watch the initial presentations from this research fellowship from my perspective as someone who's been trying to implement and teach reproducibility in undergraduate college. And that's because of the computational infrastructure that our leaders here have put together. So the Cybergis X platform has three big upsides to it in terms of thinking about reproducibility. That is, it has a virtual computational environment in which you can install essentially a virtual computer and load that computer with specific software versions. So that means if I use QGIS version 3.10 for research, compiled against a couple of libraries of Proj4 and GDAL that are specific to my research, I can give the parameters for that to one of you, and you can create a computational environment in Cybergis to replicate the exact configuration of my computer the way I conducted that research, in case any of those particular parameters or software versions had a significant impact on the results. It also has a data repository. So this is a great means for making data open and publicly available. And so as much of the data that goes into our individual research projects as we can load into the Cybergis infrastructure, that data then is there and available for other researchers to try to replicate and reproduce our work. And finally, the really exciting component of it is doing our research in Jupyter notebooks rather than point-and-click procedures with different software programs, right? And so this means we can integrate our narrative about our project with the code that executes our project, creating a very tight connection and link between our methodology and the procedures for executing that methodology. And this really means, and this is super important, starting with the raw data as it was collected and taking it through every single transformation of that data to the final product, including all of the boring and nitty-gritty processes of doing things like removing outliers or managing missing data or clipping the extent of the research. All of those decisions, as we know, are really important to the outcomes of geospatial research, and a misstep or ambiguity in any one of those can cause your research to be irreproducible. So it's important to include everything right from the very beginning. The other part of it that Peter and I are probably going to be spending more of our time on with you is the social and institutional infrastructure for this. So one component of that is pre-analysis planning. So essentially documenting and making public your theorization of a research problem and the data and methods that you intend to use to test that theory. And then executing your research after already publishing the plan for that research. And for this, we can use platforms like the Open Science Foundation, OSF.io, publish a pre-analysis plan, give it a DOI, and then once the final study is published, to link to that original plan as well, like cross-link these things. It means having open publishing, so journals with editorial standards and software standards that are using reproducibility as a standard for publication from pre-analysis all the way through to the final paper, and publishing all the supplementary materials of research, including citations and DOIs, so that all components of the research are cross-linked and cross-referenced. And then my biggest interest in this is the educational component, where we're really trying to teach three different things here. One is an audience of researchers like yourselves. How can we help you conduct and publish reproducible research? Second is an audience of maybe graduate students, teaching students how to conduct and publish reproduction and replication studies. And then the third audience is maybe the undergraduate or graduate students, trying to use reproductions and replications as pedagogy. And I'll be working on this component a lot, and trying to take some of the research that you all are doing and bring that into an undergraduate classroom to teach geospatial methods and content on COVID-19. So this brings us to our final reiteration of project objectives. I don't know, Peter, do you want to take this back? Or I can do it.
Either one's fine. Go ahead, Joe. I can jump in if you want.
Okay, so to wrap this up quickly, the number one, we want to facilitate the adoption of reproducible research practices by this group of researchers, the GSI fellows. So some of the things we'll do to try to help you with that are building a template Jupyter notebook for your research, and getting to know your projects and plans individually, and kind of consulting with you as individuals on improving the reproducibility. Our second goal is to conduct some reproductions and replications of your research, bringing that to the public and to classrooms that we're working with. And so we can work with individuals from this group in publishing pre-analysis plans and publishing those before you start your methodologies. And we also plan on hopefully writing some white papers of specific reproductions or replications. And then number three, we'll be creating educational materials to accelerate the adoption of reproducible research practices in the geographical sciences. So we're working on developing a workshop series on reproducible research practices, starting with a presentation like this one, and developing teaching modules based on the fellows' research. So thank you so much for the time to introduce our project, and we'll be happy to answer questions or start individual conversations as this moves forward.
Peter and Joe, that's great presentation. I really enjoyed it. I think this is exactly what we wanted to hear, and I guess I think this is a lot of useful information for the team. So I guess I'll leave the floor open to the team for the questions. See if you have anything for Peter and Joe.
Well, I have a question. Peter, can you talk more about the covered law?
Oh, the covering laws?
Covering?
Sure, yeah. So that's just this idea that, like if you think of something like gravity holds everywhere, right? There may be certain relationships or effects that we only see hold in certain places or certain times, right? So, it may not hold in all locations or all times, just thinking about it geographically. It may be something that only holds in certain places and times. So one of the big debates in our field of geography from 50, 60 years ago is whether or not as a field, we should be trying to drive towards these sort of universal laws, or whether we should try to be focusing on describing and explaining what's happening in different places. And sort of an in-between thing between there is middle range theory, essentially this idea of looking for relationships and laws that hold over many locations, but perhaps not all locations. Mm-hmm. So that's one of the things that, Joe and I are talking about as R&R really facilitates that march towards generalizability, recognizing that in studying things that are explicitly spatial, you may not be able to get all the way towards universal laws, but something that applies in certain locations and times. So.
Great, thanks.
Sure, no problem.
This is Danny. Thanks for the presentation. It was fascinating. So as somebody who's teaching geographic philosophy and such right now, and talking about this very debate, I mean, I've always thought it's one of the wonderful things about geography is we can kind of go both ways. In your looking at the COVID, at the initial COVID studies that are coming out, are there hints that certain things may be, certain ways of treating it or certain successes may be geographically different from between different geographical places?
I guess I just thinking a little bit off the cuff, the population pyramid is so different in some different regions of the world that I think I don't know that there's hard evidence of this yet, but at least anecdotally, the progression of the pandemic has been very different in places like sub-Saharan Africa, where you've got a very different population pyramid, few elderly people and few people with long-term chronic conditions out in, which are our most vulnerable group. So you've got population geography differences across different regions that are having a pretty significant difference on the outcome of the disease. And then another thing is that these work to try to create databases of government interventions and their impact. We also have very different outcomes based on things like party affiliation and news source in the United States. So the same intervention has different incomes in different places based on politics and information flows. So just two thoughts there.
Yeah, and I would add from the spatial analysis side, looking at some of these this summer, it's been about a month and a half since I've looked at them, but you know, a lot of the kind of more geographic studies have been locked into the data streams they can get. So they run into classic problems like modifiable aerial unit problem, for instance, and ecological fallacies because they just don't have the data. And some of the studies recognize this, some of them don't. But if you're talking about what effects are they actually finding and how reliable are they in different places, it's hard to know, I think, in some extent, because these are classic problems that we don't have answers for. And when you're locked into data that is, you know, necessarily aggregated for privacy reasons or things like this, it just gets tricky to know how much to trust effects in different places. And that's the kind of thing that, as Joe was alluding to, you know, it'll come with time and sort of like meta-analyses and things like that. But we haven't really seen that emerge yet for understandable reasons. And I don't know, unless we sort of like set ourselves up in hopefully these very reproducible, replicable ways, that we can necessarily do those analyses just yet. So those are kind of two quick thoughts, I suppose.
Thank you.
Okay, thank you, Joe. Yeah, go ahead. There was another question.
Yeah. This is Srinshri from Dartmouth College, and thank you for the great presentation. It's really inspiring, and I think this is a good timing and a very important topic. So I think it's good and important because I do have this problem in my own teaching and also research. I think especially for teaching, for undergraduate teaching, this is I think the biggest challenge for doing this kind of is the topic, is how to choose the topic. So I'm wondering if you guys have developed or maybe it's formalizing or thinking about a pilot case study to show people, demonstrate people, this is a good example for doing this for undergraduate teaching. Because based on my own teaching experience, it's very hard for me to find a very good example to do this. I'm teaching a class called Mapping Health and Disease. Basically, it's a spatial analysis for health analysis. And there's all kind of challenges. So this, for teaching undergraduate, this issue is even more challenging than the reproducibility and the replica in research.
Right. Yeah, I'll just quickly say that if we were slightly better scholars, we would have a publication to point you towards, but I'll pass it to Joe to tell you about how he's been working on that recently and incorporating into his own classes. Yeah.
No, Peter is an excellent scholar. I'm the one that should be slightly better. That manuscript's on my desk right now. So I've started teaching reproducibility in an undergraduate advanced open source GI science class. And so 2 examples of papers that I've used that are also relevant in this context. I grabbed one paper that was mapping at a subnational level vulnerability to climate change in Malawi. And it's just a multi-criteria analysis. It's not really all that sophisticated, really, in terms of the techniques. But we kind of created a PostGIS server and learned the SQL code, the spatial SQL code to reproduce that paper. Ultimately failed because of unavailability of some of the data sources, but we were able to do like 80% of the paper. And another one I've used, there's some papers out there using sources like OpenStreetMap to analyze like accessibility of healthcare facilities in sub-Saharan Africa. And so if you look for papers on like accessibility analysis and data sources that are open, like OpenStreetMap, some of those can be reproduced and also don't have super complicated methodologies. Those papers were more novel because of the data source and the region that they were applied to.
So in that case study, in a few examples you used in your class, did you find the reproducibility or replicability issues? So you said you could only reproduce 80% of it, and what the 20% of it? What's that?
And we documented them.
Okay.
And we also tried to convert the original paper into a fully, like just a running R script. And one of Joe's students did that and got it pretty far along. So we've done a bunch of work trying to build out these things, and also kind of building the actual teaching materials around it so people learn the different components of the process. And that's really what we want to connect with all of you guys to do with your own COVID work or other work even potentially. So if you're particularly interested in this, I mean, Joe's right around the corner actually from where you are. But we'd be definitely happy to work with you to try to work that, to build that into your own work and your own teaching, to be sure.
Okay.
That's kind of our purpose.
Oh, sorry. Just to bring that back and make it more specific to this fellowship, I noticed that there is an accessibility analysis on the CyberGISX server. There's also a vulnerability analysis layer. And those, I think, both have Jupyter notebooks that you can load into your own account and run on your own. So those are actually ready-made reproductions already. As long as, and I don't know if we could speak to Anand and Xiaowen whether they want a class of 20 all registering for their own accounts on this platform and reproducing those papers, but it's certainly technically possible.
Yeah, I really hope that through this fellowship, through this project, we can come as a group. We can come at least a few, if not tens of, as a few good case studies that we can use in our own classroom. That'd be a great achievement of this, and good typical example of the reproducibility and replicability, and especially for health issue. Not only limited to COVID-19. COVID-19, of course, is fashionable, but if not even limited by, but just come up with a few good examples that we can use in the classroom. That'd be a good achievement.
Yeah, Joe and I are gluttons for punishment, so anytime anyone's interested here or otherwise, we're happy to add on. But I think Anand, do you want to take us to someplace, or are you jumping in there?
Yeah, I just wanted to echo Joe's point. We are okay to have like 20 people from a class trying to reproduce those notebooks. That's perfectly fine. Yeah, and we want people to do that. That's something. One thing I wanted to ask you and Joe was on the in terms of the template that you were planning to create for this, and I think we'll be happy to host that as well in the environment if that's something you're interested in.
Yeah, we were going to follow up with you guys on that one because you obviously have as much expertise as we do there. So just an initial thought in terms of making it a little bit easier potentially for some of our co-fellows here who don't have as much experience. Having some code wrappers in the beginning that like pull the environment and packages and stuff like that, for instance. So simple stuff.
Sounds good. Yeah.
And I'd like to say, like, I'd love to be one of your case studies, right? Because I have no idea about Jupyter notebooks, right? So to be like almost an autoethnography as I go into this world. And then how do you make it accessible for people who aren't in this part, and then also kind of looking at the spatialization of race and the racialization of space. And how do you capture that? And then how can you reproduce it in different places across the country? So I'm
right. And those kind of objectives really speak to kind of the larger goals of the GSI, I think, in general, of trying to come up with standards beyond just like having templates, but sort of what are the standards of practice? Like Joe was saying, the social institutional pieces that we need to build this out, hopefully larger beyond COVID or, you know, things like that. So for sure, Ruby, we're on board.
right.
Shawan, you had some points.
Yeah, very quickly. Great talk. Enjoyed very much. I think I was going to ask just a clarification question because some of you already touched upon, I would say, suggestions for what we potentially will do together. I just want to ask Peter and Joe to maybe summarize how you would envision your interactions with the fellows. What you need from the fellows. I was certainly appreciative of case studies. People seem to be motivated to contribute their own experiences. So these are great. Could you build on those and summarize what do you need from the folks, and what would you return to them as benefits and rewards?
Right. Yeah, I think one of the initial things, Shawan, it's a good question because we were going to kind of reach out to everyone kind of collectively, but also individually to kind of see what they think their projects will entail. Because depending on what people are trying to do, they may need kind of radically different things. So our first step is really going to be getting a sense of what everyone's trying to achieve beyond reading the short descriptions of the projects that we've seen already. I know Joe started to dig into the actual infrastructure side of things. So, the last couple of weeks have been very helpful, sort of getting a sense of where people stand in terms of their knowledge of the infrastructure. But I think the most immediate thing is sort of understanding what people's projects specifically trying to achieve and how they plan on using the Cybergis infrastructure. That'll be the important, I think, first step. Joe, did you want to add to that or other thoughts?
Yeah, that sounds good. I mean, I can say what I do with students, what I try to help them create a more reproducible project. And oftentimes that looks like drawing out a workflow for an analysis on paper along the lines of what you might put in a model builder in ArcGIS or something like that. Like, what are your inputs? What are your processes? What are your outputs that you expect? And then going through a process of trying to translate those ideas. If folks are not familiar with the Jupyter Notebooks platform yet, trying to work with them individually once those workflows are very explicit and translating those into code and in an appropriate platform.
Yeah, I guess in terms of what we're going to return to people, Shawan, kind of one of the immediate things that Joe was alluding to, if people are interested and sort of have a good sense of what they're trying to do, we could help them put together a pre-analysis plan. If people are interested, and that's basically something that puts forward what you're trying to do in fairly good detail, so people can refer to it even before your work itself is done. And that just is a derivative of the steps that we just outlined. And then on the teaching side of things, I mean, it's sort of a similar thing, just going down a different pathway. But if people have ideas about if they want to incorporate these things into their courses, or if they're interested in some other fellows' research, we can try to identify, which fellows have which interest and how we can put that together as a collective so that, any individual person could access it for their own work, but potentially also the wider group of us could access it. And then ideally too, we want to sort of record and make these things as available as possible so that they can be adopted by everyone, right? So those are sort of some immediate and medium-term returns that we're hoping to help people with coming around the corner here. Mm-hmm.
Thank you. As a general comment, this is for the entire group. Clearly, I hope people already have appreciated reproducibility is not a binary thing.
Right.
It's a degree. And it's a spectrum. So we hope the group would work together to understand how to characterize this as a degree of a broad spectrum. And then by doing so, we could learn how to come up with the community practices that would be beneficial to us, but more broadly, many other related communities.
If we have older studies, I was an author on a study a couple years ago on looking at food accessibility in Chicago over the last 15 years that we did an open data article and sort of a flowchart of our methodology and such that would seem pretty perfect for what you are doing, maybe.
Sure.
And, like, would you be interested in that kind of?
Yeah, absolutely. I mean,
Maybe that sort
we're
of thing.
trying to build out a whole sort of collection of these so that when we teach classes in the future, others teach classes in the future, they can pull the ones that are most appropriate to their coursework. And honestly, Daniel, if that is a step towards what you're doing in this particular COVID project and helps you sort of formalize some of those prior procedures for what you're going to do here, I mean, obviously it falls directly into what we're trying to achieve collectively within the fellowship. So, I mean, we would definitely be open to it for sure.
Okay, yeah, I'm doing more accessibility stuff. So
Yeah, perfect.
Thank you.
Yeah,
I
and
guess.
just
Sorry,
speaking-
sorry.
oh.
Go ahead, Peter. Joe.
Speaking to Xiaowen's comment, geography is still working out what our standards of reproducibility are in the geographical sciences. So working on with older studies is also very interesting to us as we try to develop what those look like in our discipline. That's all.
Yep. Thank you, I guess, Peter and Joe. I think this was a very stimulating talk and the follow-up discussion. I hate to cut it short, but I guess we have one other presentation to go through, and that would be Suhan. She will be
The whole year
presenting.
on now, we're good.
Yeah, yeah, yeah. Good. Thank you, Suhan. Take it away.
Yes. Okay, so I will share the screen.
Yep.
So can you see the slide
Yes, we can.
in the entire screen?
Yes, yes.
Okay. So I'm going to share also the Cybergis, but I will present in the slide first. So okay, so let me start. But okay, so let me open the laser. So can you see the pointer?
Yes.
Okay, thank you. So so I'm very happy to present my work here. So I will sharing how I use the Cybergis for the visualizations. I have been developing many visualization tools. So they are mostly web-based visualizations and support the linking and parsing of multiple maps and charts. So I think I can say that there are two threads in my visualization work. The first one is the more universal and reusable one, and the other one is more customized visualization tools. So the goal of the first one is to make the code that can be reused by many different users, just like you. So it should be able to visualize your own data set as well as my data set. So when other users use the visualization tools that I developed, so it should be able to be easily used. And the second one has more customized visualization functions, which are normally for developing a particular WebGIS or Cybergis applications. So in this case, the visualizations are already integrated with the server-side program and also database. And since everything has been integrated in this case, so it's not easy to cut off the code that you want. So when you want to borrow some visualizations from the interface. So in today's talk, I'm going to cover the visualization tools that belong to the first part. So I'm going to cover more universal and reusable visualization tools that I have developed so you can use to visualize your own data for your research. So first, I'd like to introduce you the map links plot, so which is the GitHub repository that I made. So MapLinks plot is an open source visualization tools that support the parsing and linking of multiple maps and charts. So it includes The quick start showing the locations of code that you need to look at. So these are the 3 notebook examples showing how to run the visualization that MapLinksPlot provides. So I'm going to cover how to use different visualization tools in MapLinksPlot. So the first one is on adaptive choropleth mapper, so which is basically a choropleth mapping tool, but an adaptive choropleth mapper is different from the traditional mapping tool. So I'll be showing you how they are different. But before I demonstrate the visualization examples to you, I'm going to briefly overview the visualization modules that I'm going to share with you and then move to the Cybergis X. Then I'll be showing you how you can actually use them to visualize your own data. So I'm going to cover what the adaptive choropleth mapper is. So like I mentioned, this is a choropleth mapping tool that I developed. So there are many features of ACM which are distinguishable from the traditional choropleth mapping tool, but I will cover only like 2 features as an example today. So ACM provides an automatic way to compute and set the same class intervals across different choropleth maps. So for example, if you check like a link or and check and set and click this set globally button, then you will see the maps like this. The difference between these maps with the previous map is that, so let me go back to the previous slide. So the previous maps have different classification intervals for each of different periods. See, the class intervals are different to another. So it is because the selected classification method, for example, in this case, the content classification method was applied on the map of 5 different maps separately. But in this case, you set the same class intervals on each of the maps. So can you see the advantage of having the same class intervals of all maps in this case? So you can have the direct comparison of the 5 maps. So it is really hard to compare. It was really hard to compare the values in the previous maps because all class intervals are different. But in this case, the class intervals are all same. So I can actually see that the percentage of Asian population has increased in the suburban areas of LA, especially on the northeast side of LA, and also in the southeast areas too. So it reveals the spatial temporal changes of the data. And the reason that it has the same class interface is that as you select a link or like above, so it recomputes the class interface with all values of all polygons in the study area of all 5 maps. So you can set the same class interface for multiple maps with 1 mouse click. So this process is actually not straightforward if you try to do the same thing using other GIS software packages. And the second feature that I would like to cover is that ACS provides the local class intervals as well as global class intervals. So if you're really interested in this, I really recommend you to look at my paper, but I think for today I need to move quickly. So ACM also supports the linked visualization of multiple maps and scatter plot matrices. So they are linked to another. And it also has the linked visualization of 2 maps with 1 scatter plot. And also it has parallel coordinates plot with multiple maps. And it shows the time series. And also it also supports the categorical visualization, which also has parsing and linking functions. The visualization of the qualitative data are different from the visualization of the quantitative data. So I made a separate visualization model. So I named it like qualitative analysis mapper in this case. So now it's the different visualization of the qualitative data. It's the coordinate diagram, and it quantifies the changes between the 2 types. So let me move to the Cybergis X. Okay, sorry. Okay, I think okay, so it should be fine.
So you could escape your presentation mode. I think your browser will be, yeah.
Okay. Oops. I think it's okay. So, oops, what am I doing? Yeah, I did escape. Okay. And the Firefox, okay. Is it really blocking my view? So, okay.
You might want to maximize the window and then.
Yeah, then it's blocking the tabs. So I will do it like, yeah, this menu blocking the tabs. So I think I have to make it a little bit smaller.
Looks good anyway.
Okay, so okay, so this is how you can use the adaptive core class mapper. Maybe it's better to. So basically you enter your input data. So it's the CSV data. It's the CSV format. So you have the track ID, and in this case, the example data are the socio-economic and demographic variables. And the other one is you enter the shape file. So this key, the track ID in shapefile must match with the track ID in CSV. So this is how you run the adaptive choroplexo mapper. So you enter the input of CSV and shapefile, which I entered here, and also you put the title of the map and also the years. The CSV, this input data has the column called years. It's somewhere. So the year column has the 1980, 1990, 2000, 2010. So I entered all years and the number of maps that we want to visualize. So I entered the 6 in this case. The label is for the column headers and also the variables. So these variables are the column headers in your CSV input data. And also the chart. So I'm going to visualize the adaptive choroplexo mapper with the stacked chart. So after you run it, then it creates the URLs like this. Then you have, it says to see your visualization, click the URL below. Then I click it. Then it shows the visualization result. So you have an option to change like the variables. And like I said, you click the link core, then it has the same class intervals, so you can compare. And this one shows the temporal trends. And I can move to another one. It's the adaptive choroplexo mapper with the correlogram. So this is also linked visualization. The thing is you click the link or, and when you zoom in, this stacked chart, then it draws out, it's the scatter plot matrix, then it draws this chart. So whenever you change the map bound, so it only visualizes the data within this map bound. So, and another example is let me close. And another one is the adaptive choroplexo mapper with the scatter plot. So in this case, it visualizes the percentage of white and the percentage of black people. And this one, it shows the scatter plot. This is white and this is black people. And you can also pick a third variable, then it changes the colors of the dots. So like for example, this area, it's the percentage of Hispanic is high, and also the percentage of black is low, and the percentage of white is low. And so, and it shows the regression line, the linear regression line, with this local data set, the highlighted data set. So on the map, you can also see the the area that and the areas, the highlighted areas on the map represent the dots here, and you can do whatever you want, and you can go back to the original view. And also on the map, you can have the lasso select, then it changes the views on the chart. So it shows the trends on this local area. And the another one is the parallel coordinated plot. The parallel coordinated plot, it's, so you have an option to change, to select the maps like this, and also you have the map lasso select, and after you do it, then it visualizes the data with the selected regions. So I think I will move to the qualitative analysis. Also, the qualitative analysis mapper, you enter your input data like this. And this is how you set the parameters. You set the title and subject, and also the file name and the layers, which is also in the input data, 1980, 19, 2000, 2010. So it's the categorical data. And also you define the input states to be, and also shapefile. And this one shows that what chart that you are going to visualize. So for this one, I should change the name because I should the neighborhood, because it can be used to visualize like any qualitative data set other than the neighborhood data. But anyway, after you run it, then you are going to see the visualization like this. So like I said, this one shows quantifies the changes between two, and also this one is for these two, and this one is for these two maps. And in this case, you can simply change the options here, and maybe I put first here, then I'm going to make it true and run it again. Then it shows the other visualizations with a different chart. So it is called a parallel coordinate diagram. No, actually parallel categorical diagram, something like that. And so another example is it's another one. So I used the qualitative analysis mapper, but this one I included some like analysis. So in this case, so I used the built-in data and I set the variables like this, and then I printed out the index, the HTML file, and also another one is that I computed the clustering. Yeah, it's clustering here, and also there's something called the sequence analysis. Then after you run it, then I use the qualitative analysis mapper. Then if you click it, so this is the result visualization. So the sequence, so it also has the result of the k-means clustering, and also it has the result of a sequence analysis. The sequence is that when you click the sequence 0, then it shows the regions that are stable over time. So it's the different neighborhood type from 1980, 1990, 2000, and 2010. So it shows the neighborhoods that have been like stable from 1918 to 2010. But if you actually change it to different sequence, then these areas are the areas that experience really the dynamic changes of the change of the neighborhood type. And also you have, so if you change it to other sequence, then it also shows the different pattern. So this one, like between this time period, 1980, 1990, so there is a dynamic change, but it's stable from 1990 to 2010. So this is the visualization of the sum analysis result. So I think that's pretty much. So do you have any questions?
cartographic question just really quickly. I'm just kind of curious. So you're basically kind of making this argument that keeping the categories consistent over time is helpful for visual comparison, right? And I was wondering if, did you think about, like with the one you gave for around the California area, you basically had the bins go from like 0 to 25 approximately, right? So visually, the saturation level of the color is kind of still a little bit misleading. Did you think about putting an absolute range of like 0 to 100% and then having it only fill like to the 20% color line, as opposed to teaching, because you're treating the very heavy darks as like maximum, but the maximum is only 20% instead of the 100% that could be living in any particular census tract? Like, it's a cartographic question, not a technical question, just a thought.
Oh yes. Okay, so first I think you have an option to select a different classification interface.
Right.
If you change it to equal class interface, then it might be, it might be the one that you want. And also, I think maybe just in the future, I'm also thinking to add a function that the user can add the class interface like manually.
Yeah. It was just a quick thought, just thought it would be neat, but yeah, sorry, a little bit of a divergence. Thank you.
Yeah, thank you for your question.
Any other questions for Sue? So I guess one of the things I should point out is I think all the things she's doing here and the libraries are all available on the Cybergis X platform. Of course, she talked about it in quite a bit of technical details, which might be difficult for different kind of audiences. But the main takeaway is, I guess, we have these capabilities and we have like experts like Sue who you can consult with when you want to do these kinds of mapping. Good. So I think we are more at, I guess we are 4 minutes more than the time we have allocated for this meeting. So I want to wrap it up. As usual, we'll stay here for a few more minutes. At least I'll stay here for a few more minutes till and answer any questions people might have. But before we formally adjourn, I want to say this is kind of the last in the initial like 4-week series that we put together. This has been, at least for us, it seemed to be quite useful from our point of view to all the geospatial fellows. So I think it was good. But we also recognized that there were some fellows who might be at different levels of stage. So, and there were some requests of having some more basic introduction to Jupyter Hub or to programming, which we did not cover here. So we are giving that some thoughts, and my preliminary ideas are that we might be holding some additional of these or kind of meeting, or more like an office hours kind of thing with this with the staff and at Cybergis X Center and GSI to help people and maybe have some kind of a agenda for each of these meetings so people can join in and ask and when needed. At least the fellows based on their interests. So that's kind of the initial ideas that I have. Maybe in the next couple of weeks, we will start it up 2 to 3 weeks from now. But I would also want to kind of get some feedback and from some, I guess, how would you as fellows see this, and how would you as fellows want more information from us? What would be the kind of the mechanisms of some feedback to us as how to make this program most useful and valuable to you as a fellow?
And I just say, for me, again, kind of coming, no experience, I like the idea of kind of the introduction, because even as I said, when I went on the line, and even kind of some of the writing, I don't know, for some reason, the writing looks, it's hard for me to engage it, right? So I'm like, uh-oh, I know I'm in trouble. Not in trouble, but I know that there's a barrier. So it would be good to just have like a very basic introduction to the Jupyter Notebook, right? And this is how much coding or how much of the writing you have to do or not. And then also what Peter was saying, for me, I think to have both of those at the same time, so even kind of this is, or maybe it could be a little separate, but this is what it is, and then this is what you can do, and then you can actually start with your plan as you learn it, right? Because then I can just layer what I already know on top of it. I sound like I'm saying what I'm teaching the students, but it is important, like, to kind of start, because I know about research, know about trying to reproduce it, but with this notebook and all of that, that's what I don't know. So to try to put those two together.
Good
But
point.
just details to get us launched, and then once we're launched, or people like me, right, it can be good.
So we will come up with some mechanisms, and like, yeah, if you have more ideas, feel free to email me or email the team to have some discussion there, since we had that mailing list set up. So so again, yeah, go ahead, Danny.
So I guess maybe I'm a middle user, I'm not sure, but certainly a lot of this is very new to me. And I think those tutorials or office hours would be very helpful. Also, though, I think that just check-ins, or I don't know, monthly meetings of the fellows, or those kind of and maybe times in network about what people are doing, or hear what some of the other fellows their progress is, would be very helpful. And in my case, a lot of my issue is sort of figuring out, since I had a couple different projects, figuring out specifically the project that and the data set that I want to use here. So
Yeah.
Other examples and such would be really helpful for that too.
Okay. Yeah, we'll definitely do some of the office hours. We also plan to do, like, I guess, two things that we had planned to do is to have a monthly webinar for the whole community, and also essentially a bi-weekly kind of schedule for all the fellows. One would be a meeting between us, and one would be like a monthly seminar for the whole community. So we are planning to do that, and you will hear more information about that in the next couple of weeks. But yes, thank you, Danny. I think we'll do that.
I mean, I'll throw out one other idea. I mean, I know this is one of the potential planned products of the entire fellowship, but I think one of the things that gets people engaged is starting to work on something. So if we have like a white paper idea, even if it's general, something like geospatial research in COVID from the fellows' perspectives, reproducibility stuff we just talked about today, the ethics stuff that Colleen has brought up. I mean, there's any number of ways we could take it, but just getting something started, and then whomever has time or interest in working on that particular subtopic, those fellows can maybe contribute more to that than other ones or something. But just getting people doing things always helps, in my experience. So just a thought.
Very good idea. Yeah.
Yeah. So Peter, I posted a paper recently published. This is one of the initial papers produced by a small group of the GSI conceptualization project to understand the intricacies of the geospatial software ecosystem. It just came out of the IGGS. So we want to have our fellows collaborate together to build on this with certainly a reproducibility, replicability angle integrated, and also with contributions of the fellows incorporated. This is sort of a more of a survey initial measure of the temperature of the geospatial software ecosystem. So the next step would be much more substance synthesized and sort of pointing out future directions with our own experience as part of this fellowship program. So absolutely right. We'll start that process. Have maybe a rough outline to begin to engage folks to contribute. So that's part of our plan.
Yeah, the abstract reads like our conversation.
Yeah, so in a nutshell, we will run weekly office hours. We will have bi-weekly meetups, and we will have monthly webinars. I think we need to see each other all the time. Hope that's not too much burden for the group, but for the weekly office hours, obviously it's optional. It's based on your availability and any requests you want to make to get feedback. But also as very tangible, immediate steps, I hope the technical sharing so far has provided enough information for your team members to be intrigued to try things out. You know, the most vivid example Sue showed is not just limited to color plate mapping, but rather it's a process. How could you use Cybergis X notebooks to have pretty interactive, you know, visual analytics built into your notebook flows and the structure. So that's clearly, as you saw, is feasible, and so that presents some possibilities. So I suspect we have a loop closed, you know, for folks to register into the platform, and then and to come up with your own examples, however simple it might be. Start with some examples and give us feedback. But also, as you do so, you are developers and contributors to this platform, just like Sue did, you know, for the past half year also. She initiated this visual analytics framework integrated into the Cybergis X platform. So there could be similar components contributed by you folks or your students, your team members. We would like to promote, and we would like to share with the broader communities.
Thank you, Shawan. Okay, so
Sung Gao asked the question whether Sue's example will be available on the Cybergis X platform as community notebooks. I quickly responded, yes, we will make that happen. It will take several weeks, but those notebooks will be highlighted as part of the gallery of the community notebooks.
Okay, thank you, Shawan. Any other questions, any other discussion for today? If not, we can adjourn. Thank you all, and look forward to meeting you again. I'll send you emails coordinating the future meetings and I guess the office hours and our bi-weekly meetings.
Thanks a lot.
Thank you. Bye-bye.
Thank you. Bye.
Have a great day. Bye.
Bye.
Hi, hey Peter.
Peter, you are muted. You are muted.
Okay. Yeah, Daniel, what's up?
I wanted, maybe this is a question for Anand. I wanted to send you that article, but I don't know. Anand, is there a way, should I just send something like that over the listserv, or, because I realize I'm not sure how to get individual like emails.
Oh, I can just put it here. My email, I'll put it in the chat.
Yeah.
Just looking for that. That's easiest.
Okay. And then I would love to talk to you all about, not right now, because I actually have a couple meetings coming up about
Sure.
And my issue right now is sort of figuring out what the data set that I want to work on is, because I have two different things and neither is they're both in formation, I guess, by other people at the moment.
Sure.
So, well, I'm working with groups of scholars or community folks. So, which is actually a none that I talked about. It's how do you do mix this kind of work with community geography,
right?
GIS. I'd love to chat with you about that in a couple weeks as well.
Yeah.
So sorry.
No, yeah, that's fine. Yeah, follow up whenever. I mean, this is where Joe and I are sort of, again, the next step for us is really to reach out to all the fellows. It's on my little notepad here of things to do. And then also reach out to Anand and Shawen on the sort of technical end of things and try to start working at it from both directions. Because like you said, people are going to need different things depending on their projects. And, you know, your project in Ruby's, you guys have probably been the most vocal in the meetings, but you guys have the more interesting kind of like mixed method out in the field kind of projects, as opposed to some that seem to be much more like pull the data, run the data, conventional. So yours are actually in some ways more interesting for what we're trying to do more broadly with the conceptualizing. So we're more than happy to work with you guys for sure. And whenever you have the time or you're ready to go, just, you know, send us an email and you'll probably get something from us in the meantime, just trying to get a feel, you know, generally from where everybody's at, like almost like a mini survey or something to all the fellows. So.
Okay.
And if you want, and if you want to share something like papers or things which might be of general interest to fellows, the fellows mailing list is perfectly fine.
Okay. You know what? I'm gonna send this article. So the first author is Marina Kolak, who's at U of C, but I've been working with her on food access in Chicago since the mid 2000s. So and this so there's an article and then a data brief, and I think you'll be more interested in the data brief.
They go together, right? So
yeah, they go together. But when you were talking, I'm like, you know, we put this together, and it was really, truly the data brief was not as much me as the folks at UIC or U of C, sorry. But we tried. The whole idea was recordability, so I thought.
Cool. Yeah, and it's neat across space. There's an opportunity, right, to sort of do this scoping thing in different spaces. So will if you keep the same model, but the parameters change and you move it to a different location, that's an interesting sort of type of replicability in some ways as well, right? So there's lots of stuff to play with. And then Anand, to your point before, I'm gonna have to send you all my papers to shamelessly self-promote myself.
Yeah.
I'm kidding.
Well, yeah. I think. I talk to my students who are trying to figure out their master's thesis about this, but I think within geography, that is a pretty usual kind of replicability that we do.
Yeah.
Right? Yeah. I had some questions I think talking about replicability is the same time as talking about ethics. And,
I had a whole slide in that
IRB coordinator, so
I had a whole slide in the presentation about ethics of reproducibility, like the case for it. But I took it at the end and X'd it out just for time. But certainly something we can return to in either future conversations or future series or whatever. I think there's a pretty strong ethical case for replication. I mean, even just think of the research that we're doing in this particular project as sort of like, technically it's supposed to be a public good, right? That's the argument people make why we spend taxpayer money on these kind of things. So making sure that research is reliable and accessible is sort of part of the public good nature of what we're supposed to be doing. So there's a pretty strong sort of like normative case there as duties as scientists for, putting out this kind of work. So.
Well, and like in terms of IRB, remember that like, the wonky IRB wise, but the Belmont principles that IRB are based on include one of the pillars is sort of how important, how good is this outcome to society, right. And so there's and there's a justice. There's three. One is justice. One is that good to society, and the other is sort of personal protection.
Right.
And which is the one that comes up all the time. But those other two are important too. And unfortunately, sometimes IRBs forget that. It's
Yeah, and these are the kind of things that I think Colleen alluded to this last time, but there's some initiatives in the field more generally that are trying to deal with, I don't want to say balancing those things, but coming up with systems that address each side of that. So
Mhm.
particularly on the private data and confidential data side, they're trying to come up with like essentially like data passports so that you as a researcher can access confidential data or private data that's housed on certain servers in some format so that you can try to reproduce or replicate pre-existing research. I know they're working with the University of Michigan and they're a big repository there to try to build that system out. That's a Doug Richardson, Mapo Kwan led project.
Right.
no,
So there's stuff going on, right?
it's wonderful.
Yeah, there's kind of like lots of little pieces all over the place. And the question is, in the next 5 years or so, can we start to sort of coordinate them into
Yeah.
shift in how we do the work in the field, I think. So,
You know, just speaking as a person at a small university with a small IRB,
sure.
you know, for us, a lot of these issues, you know, like we have a half-time IRB
Mhm.
person plus
Mhm.
me. I get one class off. So, I mean, it's, we don't really have the resources, like when we're doing NSF grants that call for this data plan and such, like
Mhm.
we don't like, if we could sign up or have, let's say U of I and the state universities of Illinois came together to have, I think there's actually been discussed to have some sort of data vault, I guess, with different kinds of permissions and and some, you know, came together to do that. Something that would be wonderful for us. I mean, because a lot of our issues are the ability to kind of provide oversight,
Mhm.
both on sort of the science end and on the both on the actually experimental end, like giving out and sharing data, and on the
Right.
IRB privacy end. And it worries me in terms of small universities actually even like being leads on research grants
Mhm.
where that's required, but coming together, you know, paying some sort of subscription fee or something, I don't know, would be very helpful.
Yeah, and it's tricky too because it kind of like you're suggesting, it limits the extent of what you can do. So it's, you know, if you're doing a fairly simple study that has good precedence, you know, it's easier to do the IRB, right? Because you have an established understanding and there's templates and
which
things.
most of the studies at CSU would be.
Right. But if you're trying to do stuff that's a little more complicated, mixed methods, bringing in new methodologies, the stuff that really pushes the frontier forward, you know,
Yeah.
like that's where the interesting questions for R&R are, because you're starting to blend together multiple fields and multiple ways of understanding. You know, the provenance systems are totally different. The ontological systems are totally different in different fields. And, you know, getting the IRBs together for that, and even just trying to build out the how you're going to record all the stuff
Yeah.
is much more complicated and difficult for small institutions. Like Joe's at Middlebury College,
Yeah.
which is a
Yeah.
great school,
Yeah,
but it's a smaller
interesting.
school, right? So
Yeah.
when we're collaborating and putting in grants and stuff, it's always this give and take between ASU and their larger institutional capacity, and, you know, Joe on there and sorting all that stuff out. But it's been
Oh, when I've
Yeah.
been in that situation as the both as it's the IRB person, but also as a researcher applying for a grant, and it's pretty funny. There are research, you know, the grant folks will write me thinking that I'm in their grant in the CRSU grants office, because
right.
you know,
Right.
but I have to get it all together myself.
Yeah, that's Joe. Joe's in the same boat. He's like half grant officer, half research.
Yeah. Oh, it's tough. Thank you. I will post that. I have to go.
Yeah, I'll keep my eyes open
Thank
for
you.
it. Oh, I'll add, you know, just real when you email me, I'll CC Joe in so you have his email as well.
Actually, I think I'm gonna just put the article up on the.
Oh, perfect. Yeah, that works.
Yep.
And we'll follow up later as always. Anan, I'll talk to you soon enough
Sure.
about stuff too. But
Yeah.
thanks for hosting and hanging around here. So
Yeah,
Thank
thanks,
you.
man.
Thank you.
Bye.
Bye-bye. Bye-bye.
I'll talk to you guys soon. Bye.
Yep, bye.
Bye, thank you.